A bank offers two one-year loans X and Y. Loan X is with inflation protection and loan Y is without inflation protection. For each loan, repayment of all principal and interest is made at maturity and there is no default risk. The following are expressed as continuous per annum rates. The compensation for expected inflation is 3.5%. The sum of compensation for unexpected inflation and cost of inflation protection is 0.6%. The actual inflation rate turns out to be 2.1%. The principal amount for loan X is 7,500. The repayment amount for loan X turns out to be equal to the repayment amount for loan Y. Calculate the principal amount for loan Y. So it's just basic continuous compounding with these extra inflation things thrown in. And the thing to remember is that since for loan X, they don't buy the inflation protection, so they will undergo the consequences of the actual inflation that happens. So the actual inflation that happens is 2.1%. So what that means is that if there is a rate quoted by the bank, let's say R is the rate quoted by the bank, let R be the continuously compounded interest rate quoted by the bank. Then effectively, because of the inflation, now this inflation is on top of this rate. So practically they will encounter not just this rate, but this rate plus the inflation rate, because that's how much the money will change its value as you go forward in time. So if S is the actual practical rate which the borrower will have to pay, then that's equal to the quoted rate by the bank and plus the extra inflation rate. So therefore, we know that for continuous compounding, which is constant, the amount function is PE rate times T. So in this case, let's call X of T as the amount function for loan X, and time is 1 year. So X at 1 will be, the principal was 7,500 for loan X, E power, this R plus 0.021 is the rate, and time is 1, so we don't see that. Okay, so this much for loan X. Now loan Y has inflation protection. So what they are doing is that in order to get protected for inflation, they are upfront paying this extra 3.5% for expected inflation. And then there could be some unexpected inflation, and the cost of that, they're paying an extra 0.6% for that. And as a result of that, they don't have to suffer the consequences of this 2.1% inflation. So now, right now, because of the numbers we have in this problem, it's obviously better not to get the inflation protection, because the inflation turned out to be only 2.1% during the coming year. But that's not something which you know when you are at the beginning of the year. So it's only after the event that we know that this time they were better off because of the lower inflation. So what they are doing is, since they didn't know that inflation is going to be 2.1%, in order to have a security, what they did was they paid this 3.5% extra for the expected inflation and the 0.6% extra for the expected inflation. So you would add these two costs, these two rates up on top of the usual bank rate, which we are assuming to be R. So for loan Y, the practical rate turns out to be R, which was the quoted bank rate, plus the expected inflation, plus the unexpected inflation rate. And so these two add up to 0.041. So loan Y practically pays an interest of R R plus 0.041 compounded continuously. So y1 would be principal. We don't know the principal for loan y times e power rate times t. Rate is R plus 0.041 and time is 1 year. And we are told that y1 equals x1 because they said that the amount, the repayment amount for loan X turns out to be the repayment amount for loan Y, and the repayment's happening after 1 year. So y1 is equal to x1, and y1 is PER plus 0.041, x1 was 7,500, ER plus 0.021, and so we are to find P, the principal for loan X, for loan Y. So you divide both sides by RE to the R plus 0.041, and we know by basic algebra that the exponents get subtracted when it's division, and the R's will cancel out, and you have 0.021 minus 0.041 when you distribute the negative, and this ends up being 7351, and that was choice A.